and myself. We have 5 judges who have rated all the participants' performances, and the awards are sponsored by TS Imaging. So why do we need automated vessel wall segmentation? Um, Initially, when carotid imaging started out, we had 2D carotid MRI, which basically acquired only 12 to 16 slices around the carotid bifurcation. And that was easy enough to segment for the lumen and the outer wall manually. But even then, if we had to do uh, multiple segmentations of the plaque components, it will get more tedious. And only after we do all this segmentation can we get these automated measurements, looking at different plaque component volumes and so on that are important for prospective studies and clinical measurements. Nowadays, we are able to do high-resolution 3D vessel wall MRI, and that gives us hundreds of images in a very short scan time. So, for example, in the last vessel wall challenge, we had the participants do a lumen outer wall segmentation on a 3D GRE-based sequence called 3D merge. But this has some disadvantages in that it is not widely available on all the scanner platforms. So this year, for the Cosmos 2022 challenge, we have focused on 3D TSC-based vessel wall imaging sequence, which is known as Vista on the Philips platform. It's also available as Cube on the GE platform and Space on Siemens. It's also available on others such as United Imaging and so on. So given that it's widely available, having this kind of AI segmentation, automatic and fast segmentation of this lumen and outer wall on this 3D TSC imaging can greatly expand access of vessel wall imaging and its applications to the clinic. So that's the main significance of this Cosmos 22 challenge. So this is how we have conducted this. The data has been released in April, the training data, and all the participants were invited to develop their segmentation algorithms on the training data. And just before the evaluation was going to be done, the test data was released, and the teams were asked to compile the contours on those images and submit the contours. And after that, automatically quantitative measurements were done to rank those participating teams, and the top teams were invited to present their results to the judges. We had 5 judges which span both technical and clinical aspects so that they could completely assess the performance of these algorithms. So after the SMRA, judges have evaluated them, and we have the presentation today of these 5 participating teams, and the winners will be announced on Friday. And there will also be a follow-up MICAI online event, which you are all welcome to attend. So these are the quantitative metrics we used. It was comprehensive, taking into account the most important characteristics for vessel wall imaging, namely the dice coefficient, the lumen area, outer wall area, and also the half-dot distances, looking at the smoothness of the contours. And also we looked at the Cohen's kappa of how the participants' evaluations agreed with the real carotid atherosclerosis diagnosis. So based on this, we have 6 teams, and 5 of these teams will be presenting today. So finally, the judges were asked to do a qualitative evaluation. This is mainly because a quantitative metrics do not fully capture everything that is important for a clinically significant quality of the algorithmic performance. So what we looked at was image quality and whether the segmentation algorithms can perform well near the bifurcation when there were flow artifacts, when was poor fat suppression, and so on. So all the participants were evaluated on 4 metrics: contour smoothness and fitness quality, and the segmentation near the bifurcation, and also when there was real plaque instead of just a normal wall. And finally, whether there was a good performance in whether if there was a low image quality or artifacts. So after that, we have this final evaluation to be done, and the results to be announced on Friday. So look out for those. So now we can move on to the next part of the presentations, which will be the online presentations.